Hello everyone. In this video, I'm going to be going over the Module 7 Master TA lecture for CIT 247. So the lecture topics today will include problems on routers, how to find issues on routers, and a demonstration in GNS on router issues. So let's first look at the list of problems you may encounter in this week's lab. So when devices router separated LANs cannot communicate with one another, you should look for the following misconfigurations. So first we have disabled router interfaces. Similar to switches, you may find in your LANs that router interfaces that need to be up are actually down, administratively down. So you need to re-enable those. The process is the same as re-enabling a switch interface. So also, routers have a lot of exclusive issues that you won't find in a switching network. So for example, there's missing routes. So so when you're troubleshooting your lab, you want to look at the routing table for the routers you're working on to make sure all the necessary routes are on them. Because if a router does not know where to send a packet, that will actually will keep computers from being able to communicate with one another. Another thing to keep an eye out for is overlapping subnets. So you've just learned about subnetting a few modules ago. This will be a good test for your subnetting knowledge. Now, we'll discuss overlapping subnets in a minute or in a while, but just know that this occurs when two LANs have subnets that actually overlap or share addresses with one another, which can prevent communication. Finally, incorrect routes. This is more common when you change the subnets, or when you resolve the overlapping subnet issue. You may find that there's still route to old subnets, and you want to make sure you change those routes after you change overlapping subnets. So let's go over the processes we use to find layer 3 issues. So finding layer 3 issues requires you to be proficient with two different commands, ping and traceroute. You're already familiar with the standard ping command, but you need to understand extended pings when working with layer 3. Extended pings select a specific source address to start the ping process from. This helps you determine if a certain subnet can communicate with another. For example, the illustration below shows router 1 pinging PC1 from its serial interface. So here's router 1 here. So we're pinging from this interface to the side that's not in the same subnet as PC1. You can see that in this purple window here. So this basically, the purpose of doing this is to test connectivity between this subnet here, the 192.168.10.0/30 subnet, and the 10.0.0.0/24 subnet. So even though router 1's Ethernet interface can ping PC1's Ethernet interface, that does not mean that the serial interface can do so. So that's why you would want to check. That's why you would want to use this, extended pings like this. You just type in the destination, you type the word source, and then you type in the source address from where you're pinging from. So another command you'll need to use is traceroute. So this is a command that traces, as the name implies, the route hops a network uses to reach a destination address. This can help you track the location of connectivity issues. And here, note the picture here and the blue circle. So we're in PC1. We're trying to we're using the trace command. In fact, you just type trace in the PCs, and we're putting this address for PC3. Now notice here that if PC1 can ping or successfully reach or ping a certain interface, it'll list it here. So it can ping between the routers or its default gateway. Then PC1 can successfully ping router 1's F1/0 interface, which is this address. However, everything else with the little stars, it means it can't reach. It means it's not reaching anything. So this is where the problem, because this route from the S0/1 interface on router 1 leads to this PC, we can assume that there may be a problem between these two serial interfaces between router 1 and router 3. So finally, let's discuss subnet overlap. So when examining your topology for your lab, be sure to watch for subnet overlap, which is where two or more LANs have IP subnets that overlap with one another. For example, you have 192.168.0.0/23, and you have the same address or subnet number with /24. This is a pretty obvious subnet overlap, but in your lab it's going to be considerably less obvious. But I'll show you how to deal with that. So after you find an overlap, change the subnets in a way that uses the lowest number of available subnets, and be sure to not change any subnet masks. So for example, what this means by lowest number of available subnets. So when you change, so let's put it this way. So subnet masks determine how big a subnet is. The smaller the subnet number, the bigger the subnet will be, or in other words, the more addresses will be in a subnet. So for example, let's open up a WordPad window. So 192.168.0.0/23, we have one subnet here. The way to determine the size of a subnet is to find the subnet's broadcast address. So my videos have already shown you how to do that with like the magic number method. So the magic number method here, I believe, would be 2. Or 1-255, and you know for finding a broadcast address, you subtract by 1 for the interesting octet. So here we have the subnet for excuse me. So this would be the subnet for here for this address. This is the broadcast address. This helps you determine the size of a subnet. So basically, /23 takes up 2 of /24, if you will. So you'll want to change the /24 address like this. 2.0/24. Because if you change /23, you would have to start from 1. Or you would have to start from basically 2 as well, but it would take up even more space. It would actually go from 2 to 3 instead of /24 remaining in the .2. So hopefully that makes sense. But basically, you want to limit the size or how many addresses your subnets take up is a best practice for when you're in the real world, where IP addresses are pretty limited, at least IP4 addresses. So finally, after you change the subnet, be sure to change the following in your LAN. This is very important. So there's a number of things you need to change after you change the overlapping subnet. For example, the PC IP addresses and default gateways will need to be changed. You'll need to change the router IP address or interface IP address or the default gateway for your PC. Finally, routes on other routers connected to the new subnet will need the routes changed to match the new IP addressing. So now we're done with our PowerPoint. We're now going to have a little demonstration here. I'm going to showcase 2 different problems in this network. This network here is not unlike the one you'll be working with in your course. I've only configured these for time. These addresses and devices are configured here. But let's go ahead and try something here. So when you get into your network here, the first thing you're going to want to do is do some ping tests. So see what pings, see what doesn't. So like 1 or 10.0.0.1. So we could ping the default gateway just fine. Let's try to ping PC2 from PC1. 8.7.254. So we're getting a timeout message. Now what this could mean, now you probably noticed, let me start this way. So you probably have noticed throughout your work in this course that there's 2 types of error messages when you do ping. Like there's destination not reachable, or there's timeout. So basically timeout typically means that your ping made it to the device, but the response was not able to come back to the computer. That's what it's typically going to mean in a layer 3 network like this. Destination unreachable pretty much means you can't reach the destination at all, as obviously the name indicates. So what is wrong here? So I'm going to, for sake of, so basically what you would do here, we could do trace 192.168.7.254. So we can reach, so something is up here. Now trace isn't always very accurate. This is actually an incorrect indication of where the problem is, or technically. So basically, the problem here is router 2, and I will show you why. So let me boom this up a little bit. Oops. Okay. So the problem actually lies in show IP route. So if we were to actually go through router 1 and 2, we would find that everything's pretty much okay. Our problem is in the routing table of router 2. So basically, our problem here is that router 2 does not have a route to go back to the 10.0.0.0/24 route. So basically, because this router 2 is not adjacent to router 0, basically what you would want to do is configure a default route. Basically, pretty much most of your routers should have a default route in your lab. So basically what we would do here is configure a default route. So let's go back to PC1, try our ping again. Might take a little minute. There we go. So yeah, as I've said in previous videos, if you have a few timeouts, it's okay. Basically the ARP process is happening. That's why you see the initial timeout message. If we do this ping again, yeah, everything's fine. So basically, that's one thing you want to look out for. Now, I did skip some analysis. So basically, when you try to do the trace and ping command, you want to look at each router, look for any missing routes, like a default route, and that's basically all there is to that kind of problem. Another problem you might notice here is that we have overlapping subnets in this network. It's between the router 3 network and the router 2 network right here. So so the way we can figure this out is by writing out the the subnet ID and broadcast address of each network here. Now I've already taken the liberty to do that. So if we take a look at the router 2 network, it starts at .0.0/21. So the magic number for /21 is 8. The interesting octet is this, the third one. And 255 is the last available is the broadcast address for most subnets. So excuse me. So that is the range of addresses in the router 2 network. Now, if we do the router 3 network, it starts from, we would just basically write down the subnet ID. But when we take a look at the broadcast address, magic number for this subnet is 2. So we do 3 for broadcast address, we subtract that by 1, and then 255. So you can see here that these addresses are actually within these. They overlap with the range of router 2 network, or the router 2 network. The way to fix that is basically to see if you could start right after this address here. Basically what you want to do is see where the bigger network ends, and then you want to use the lowest available subnet after that. So in this table here, I've created a new network that starts with .8.0, and that works because the last available address, or the broadcast address in the router 2 network, is .7.255. So that leaves .8.0 open for the subnet. So one thing you need to make sure is that the subnet actually starts on that number. The way you do that is basically learn the magic number pattern for a specific mask. So it basically, the /23 masks start, the subnet ID for the /23 masks are every 2, so like .8, .10, .12, and so forth. Well, /21 is every 8, so it's like .8, .16. So that's how you figure out what new subnet to put in your network. So that's pretty much it to this video. If you need any help in the troubleshooting lab, be sure to email me. I'll be more than happy to help you. Thank you very much for watching this video. I hope you have a good day. Thank you again.